Thank you. My Polish isn't very good, but I think what she said is, you're now prepared for the closing 6-hour keynote. Yeah? 6 hours? No? 60 minutes. How about that? Yeah. Well, have you enjoyed yourself so far today? Has it been a good conference? Yeah? Let's give the conference organizers a round of applause. Yeah, it's been a very good show. Well, this evening, I want to leave you with some thoughts about where the future of software development is going, and specifically web services. We're going to be talking about web services in here, but we're going to be talking about RESTful web services and a resource-oriented architecture. This is a topic that's very near and dear to my heart. I run a consultancy in the States called thirstyhead.com, and our focus is on Groovy and Grails, certainly. I write a series of articles for IBM Developer Works. These are absolutely free, Mastering Grails and Practically Groovy. If you Google these articles, you'll get a lot of information about that. But what's nice is Groovy and Grails are an implementation language. I could be writing these articles in Ruby or Java or C# or anything. The things we want to focus on here tonight, this idea of RESTful web services, really transcend any particular language. The language you write it in is just kind of an implementation detail. These are much higher level concepts. So in my book, Groovy Recipes, I have an entire chapter dedicated to using Groovy to making calls, not just RESTful calls, but SOAP calls, XML RPC calls, these kinds of things. In my book, GIS for Web Developers, which is all about how to build your own Google Maps, create an entirely open source Google Maps-like application, finding free data and free command line utilities and free databases and free web services. The examples are all in Java and Groovy, of course. But the important thing is, in this book, GIS for Web Developers, I focus on a set of open web standards put out by the OGC, the Open Geospatial Consortium. This is an organization that predates the W3C. It's older than the World Wide Web Consortium, and they've put out a set of RESTful web services. So this is kind of getting you into the mindset of what we want to start focusing on here. Now, when we're talking web services, I want to first focus on the web portion of that, and then we'll spend the majority of the talk on the services portion of this. But I think there's no better book out there to kind of explain what we're talking about here than this one, Small Pieces Loosely Joined. Have any of you read this, by the way? Any of you read Small Pieces Loosely Joined? No, I just reread it recently. This is not a technology book that's full of semicolons and curly braces. This is a book about the philosophy of the web, the philosophy of the World Wide Web. And this title, Small Pieces Loosely Joined, really kind of describes what we do as web developers. You can pull down a little HTML from here, and a little CSS from here, and some images from here, and MP3 files from there, right? Yeah? All of these different small pieces are pulled together in our browser. And we can talk about it in a kind of abstract sense, or we can start putting some real brand names behind it. I'm not going to write my own credit card processing system. I'm not going to write my own mapping system. Oh, that's a bad example. I did in GIS for Web Developers. But normally I would use PayPal for credit card processing, Google Maps for my mapping needs. Even YouTube, gives you the ability to embed YouTube videos right in the middle of your web page or your blog. So you can see that in this kind of Web 2.0 generation. Web 1.0 was very good. It was the first 10 years of the web, just getting the information out there, getting people used to clicking on the browser and the back button and things like this. And Web 2.0, we're beginning to see a bunch of services pop up that we can begin mixing together in our web pages. So certainly web is an important part of this equation. You know, this is all running over the World Wide Web. It's running over TCP/IP. It's running over HTTP. These are all the core technologies, of course. But it's the service aspect of this that's really changed things. The idea now that being able to provide the data is just as important as being able to provide the web page. You'll know eBay, don't you? eBay, yeah? They run auctions. Yeah? They have both a web page, ebay.com, and they have a set of APIs as well, web services. Any idea how much of eBay's revenue comes through their web services? Over 2/3. Over 66% of their revenue comes not from ebay.com, but from their web services. eBay being cut down to 1/3 of its size would still be a giant company. But imagine being 1/3 of the size, or being able to triple the size of your organization by being able to offer a data set of APIs. When we start looking at the modern, the Web 2.0 darlings, the Facebooks and the Twitters and companies like that, it's a requirement that they provide an API as well as the web page. Less than 15% of Twitter's traffic comes in from Twitter.com. 85% of Twitter's traffic comes in through their web services. So you'll see this is a real phenomenon. This is something that we need to address in our organizations. Now here's a little test. Let me see if I can read your mind for a moment here. I'm concentrating. When I say web services, what do you immediately think of? Soap, don't you? Yeah? I'm not here to knock soap, but show of hands, how many of you are doing soap development in your organization right now? Oh, okay, yeah, some, yeah. Soap is just one implementation of web services. And what we'll find is that SOAP is very much a Web 1.0 kind of technology. SOAP came around in the era of about 1997, 1998, 1999, right around then. So this was our first attempt to deal with web services. It's not the last one. There are plenty of other implementations we're going to talk about in here. But that's really important to not conflate SOAP with web services. That when I'm talking about web services, oh, he must mean SOAP. Bear in mind, this is one implementation, not the only implementation. And it's interesting because Dave Weiner, the creator of SOAP, he wasn't the only creator, of course. He was there at the table with Microsoft and IBM and the rest of the folks. But you see that he has been big in the space. He was the creator of XML-RPC and the creator of RSS. We'll talk about that later on. But in an interview on IT Conversations, about 45 minutes into the interview, the interviewer says, "Man, Dave, why do you hate SOAP so much? Why do you go around bad-mouthing SOAP all the time? This is your baby. You created it." And Dave says, no, don't get me wrong. I love SOAP. SOAP was the lawyer of the family. I love that. SOAP was the one that was supposed to bring us all together. We're all supposed to be holding hands and singing Kumbaya together. Yeah. But clearly that didn't happen. Clearly, the magic of SOAP has failed to occur. These are strong words from the inventor of the technology. And what he means by this is this, that there are some technologies we use day in and day out, and it's kind of faded into the woodwork. Quick, what version of HTTP are you using? 1.1 is the answer, but HTTP is a technology that we use. It's ubiquitous, but we aren't constantly faced with what version of HTTP are we using and incompatible versions released by different vendors. Quick, what version of SOAP are you using? Is it Microsoft SOAP, or is it Apache SOAP, or is it JBoss SOAP, or is it this version or that version, right? And so this is Dave Weiner right here. He says this is why we have to call SOAP a failure at this point. We wanted SOAP to be this great equalizer. We wanted SOAP to be so ubiquitous that it would fail into the woodworks, and we would have grandmothers out there publishing SOAP web services of pictures of their grandkids. Has that happened? Maybe grandmothers in Poland are smarter than American grandmothers, but I don't think so. My grandmother is not writing SOAP web services. So we begin looking at usages in the wild once again. By the way, this is Tim O'Reilly, publisher of O'Reilly Publishing, the books. And he was talking to folks at Amazon. Amazon offers SOAP-based web services and RESTful web services. They don't have religion. They said, we want to sell books, and so we'll provide whatever mechanism we can. Based on real-world usage patterns, over 85% of their traffic comes in through their RESTful interface, not the SOAP interface. Both provide equal functionality, but when put out to a vote, the developers overwhelmingly are choosing REST over SOAP. He goes on to say this is Tim O'Reilly as well. He says, despite all this corporate hype, and that might be a little bit harsh, but all of the awareness of SOAP, all the corporate support of SOAP, there are endless articles and books and magazines about SOAP. Despite all of this, it just hasn't caught fire. How long are we going to wait for the magic of SOAP to occur? He says it's these technologies with these low barriers to entry. Simple XML over HTTP. We all know POJOs in here, right? Plain old Java objects, yeah? These web services he's talking about are called POX web services. That doesn't sound nearly as nice, but plain old XML web services make it tremendously easy to get this data back and forth in a very low ceremony way. You aren't constantly fighting with the APIs and the versions and everything else. So let me give you a couple of examples, and we'll have to see if the live demo gods are smiling on me right now or if they'll frown on me. But we'll see. I'm tempting fate here. That if I come into Google and I look for a RESTful geocoder. Oh, hold on. Let me make sure I'm in the American. Oh, no. American? English? Google.com in English. There we go. All right, much better. All right. RESTful geocoder. The first hit that's going to come up is this geocoder. Now, a geocoder, just a little background information, is where you take an address and translate it into a latitude-longitude point. If you ever go into Google's and you're saying, I want all the Starbucks, nearby the university, or I want to find all the McDonald's near my house. I know you have McDonald's. We've driven by them here, yeah. What Google is doing is geocoding those addresses into latitude-longitude points so it can display it on a map. And so we have this very nice free geocoder. It's got an API that only a programmer could love. I look at this and I'm in love. I say, oh, beautiful, yeah? But really what this API says is, all right, if you want to provide me a city and a country, something that looks like this, brainoff.com/geocoder/rest, city equals Brighton, UK. If I make that request, in fact, I'll get the latitude, longitude points back out of this. So let's try this with Krakow. Yeah? And you all have your latitude and longitude memorized, don't you? So yeah, this is true if you need it, yeah? Yeah? No. We can double check this in Google Maps. Google Maps will always allow you to type in latitude, longitude points. So if I come in here with my latitude and go into Google Maps and then provide it with the longitude, Krakow, Poland, yeah? Yeah. So being able to do this RESTful web service call, you can see this wasn't difficult to do at all. I didn't have to worry about envelopes and headers and things like that. I just made a simple request and got latitude, longitude points back. Let me expand this for just a moment. As a programmer, you'll see there's nothing up my directory right now, nothing up my sleeves right now, yeah. But if I come in here and write a quick Groovy script to do this, we come in and we say, all right, here's my address, yeah? And clearly that address right now is a string. But if I transform it, if I say def URL to URL, that URL is now a java.net.url. And again, I'm writing this in Groovy, but Groovy uses core Java libraries under the cover, so I'm dealing with the Java classes. There's one more thing I want to demonstrate right now. If I come in here and I say def XML equals URL dot get text, I can come in here and get that XML right back from that RESTful web service. Now, I took you the long way just to demonstrate what's going on, but if I come in here and do something like this, println address to URL text, in one line you can see I've taken that address and printed it out. I'm making live web services called across the web, yeah? But wait, there's more, yeah? Now, we're not just going to capture that. What I'm going to do in Groovy now is I can see that this starts with an RDF element, point, long, RDF point, lat, yeah? I'm going to use XML slurper. This is native to Groovy. It's going to slurp in that XML, yeah? I'm going to turn around and I'm going to parse that address. And now, rather than printing out the raw XML, I'm going to print out RDF point lat and RDF point long. Do you see how I'm walking through here? RDF point lat, getting those elements, RDF point long. Yeah? Be able to run that now and get those elements out. If you want to stand up and cheer, you can do that, all right? This is cool, isn't it? Yeah? All right. This is what web services should be. You can see that it just fades off into the woodwork. I don't care what's going on here. I'm making this call. I want to get at these latitude, longitude points. There's one more example I want to show you here, and then we'll get back to the slides. I was looking for a dictionary, a RESTful dictionary on the web. I couldn't find a RESTful dictionary, but if I come back here and I look for a RESTful rhyming dictionary, there is one of these out here. So a RESTful rhyming dictionary allows you to come in here and pass in a word, and it will return the words that rhyme with that. So if I come in real quickly and I look for words that rhyme with soap, you get back cope and dope and mope and things like that, yeah? You know, if I come in and I search for rest, we've got words like best and blessed and well. Now you get the idea, right? Really good words come out of this, right? You know, this obviously isn't my dictionary. I couldn't create that, yeah. But we can see once again that if you have this ability to make a simple RESTful web services call, then I can come in and I can use that. If I come in here and I'm demonstrating Groovy's MOP, which is the Meta Object Protocol, this is going to allow me to say, def word equals rest. And I want to print out all the words that rhyme with that. Well, of course, I'm going to get yelled at. They say there's no signature of rhyme on a string. String doesn't have that native method rhyme yet. Yeah. Every Groovy class, every Java class has an expando meta class that surrounds it. And so if I turn around and add this rhyme method to the meta class of string, I can come back in here and say, what was that address again? The address was this. Only instead of passing the word in, I'm going to pass in the delegate. So in this case, meta class has the rhyme method, and string is the delegate. And so when I do something like this, print out word.rhyme, you can see we're going to make that call, and we're going to pass it back. So in this case, I'll even just return that twirl text. So in one line here now, when I run this, I now see that whatever word I have in there, I come in here and I want to println whatever rhymes with Java. Oh, it was going so well. No, please, run. There we go, yeah. So, we begin seeing those things come out here. So let's just get Java up there so we can see it and move on. Java. Yeah? So something like this is exactly what Dave Weiner was trying to talk about. Trying to say that these web services should not be high ceremony. These web services shouldn't be anything special at all. These web services should be very ordinary and commonplace and something that we can use without even thinking about. Does that make sense? Yeah. Good. So, let's talk a little bit more about this. SOAP is clearly a specification. It was an implementation. There's a specific version of it out there. You're using SOAP 1.0 or 1.1 or whatever version you're using. What we have with REST is more of a set of architectural principles. It's not an implementation. There's no such thing as REST 2.2, right? REST is a set of ideas that we should try to incorporate. So let's explore this a little bit more. The official definition of REST is that it is representational state transfer. How's that for an expensive word, huh? We call those $20 words in the United States. Very expensive words. Representational state transfer. It's funny, what does SOAP stand for? Simple Object Access Protocol. Actually, that definition is officially deprecated. Now, SOAP doesn't stand for Simple Object Access Protocol, just as 4 letters that sound great together. Yeah. Why did they deprecate the definition of SOAP? There's nothing simple about SOAP. Exactly. The jokes write themselves, don't they? Yeah. There's nothing simple about SOAP. But yet we look at REST, which is so simple, and it's got this very complicated name, representational state transfer. It's got a very complicated name because this guy gave it to it. This is Dr. Fielding, Roy Fielding. He's one of the fathers of the internet. He's the guy who invented URIs. He's the guy who wrote the original RFC on URIs and URLs. And so in his doctoral dissertation, he coined this phrase, representational state transfer, as a way to identify how this massively distributed, massively fault-tolerant web services could be implemented. Have any of you by chance read his dissertation? Some parts of it, yeah. It's actually kind of an enjoyable read, isn't it? Yeah, in his doctoral dissertation, he's quoting Monty Python. Yeah? I mean, he's making jokes in his dissertation. You can see that REST's most zealous advocates are often called Restafarians. Yeah? So there's a lot of fun in this community as well. Not Rastafarians. No, Restafarians as we go along here. But what we end up with is a definition that we can begin looking at. SOAP is a service-oriented architecture, an SOA. And we find that it really takes a very RPC, remote procedure call, focus. It's really verb-oriented. We're going to call this method, we're going to do this, do this, do this, do this. You'll see examples in just a moment. In fact, REST is a way that you can put together a resource-oriented architecture. And we say that it's noun-oriented, but really it's object-oriented. And as Java programmers, as OO programmers, we should look at these RESTful web services and breathe a great big sigh of relief. Ah, finally. Because RPC is really state-of-the-art COBOL. Yeah? Taking this data and throwing it over the fence and getting transformations and getting it back. You know, we really want to take an object-oriented approach to our web services. So here's a hypothetical set of SOAP services. Imagine that this is the WSDL, right, coming down and explaining that, okay, you have the get user method and the add user method and the remove user method. And you ask managers, why do we use SOAP? And they say, well, because it's a standard. Yeah? But if you look at these methods, there's nothing standardized about that. You need to have a WSDL in order to interact with a SOAP service, because this service calls it add user, but the next service might call it new user, or create user, or insert user, or push user. You get the idea, right? Those method names could be anything. So with RESTful web services, what we want to do is we want to standardize. Because if we look back here for a moment, is there a user object defined anywhere? No. We see get user and add user and remove user. There's a hint of an object. We can see these are all methods, all verbs, no nouns. And so with RESTful web services, what we do is we make it noun-oriented. We make it object-oriented. We have a resource, a user, or a location. And you look at the URL, example.org/US/New York/New York City. If you make an HTTP GET request, like I was doing from my web browser, you type it in your browser, press enter, it's making an HTTP GET, you're going to get the representation of New York City back. Quick, if I wanted to query Krakow, how would I do that? /PL location /PL /Krakow, right? Yeah? A couple of you are mentioning up there, have you used this web service before? Yeah? No? No? Did you read the WSDL for this web service? No? You mean you just knew how to use it, never having seen the web service before in your life? Absolutely. Because this is the way the web works. We're used to looking at these URLs. This means something specific. Now, of course, we'll get an XML representation back of New York, but we wouldn't have to get an XML representation. It could be a JSON representation, JavaScript object notation. It could be comma-separated values. It could be anything you wanted it to be. But the idea is we're going to make a well-defined HTTP GET, and we'll get the representation of New York back. What do you think would happen if you left New York City off the end of that? What would you expect to get back if you just asked for /US/NY? A list of cities in New York, exactly. Once again, you're an expert on this web service. Congratulations. Yeah. You know, you back off New York and you get all the cities in the United States. Back off the United States, you get all the cities in the world. So you can see this is a very natural way of dealing with web services. Now, here's where it gets interesting. Because we've been focusing on HTTP GET all this time. You know, there are a number of different HTTP verbs out there. The most popular one besides get is post, right? Yeah? When do you use post? Say again? To add something, absolutely, yes. So if I'm in Amazon right now and I'm looking for books on Google, I type in Google and I get a list back of books. I get a list back on books. HTTP GET, I get a list back on books. Looking for a book on Grails, type in Grails, HTTP get the representation back. But when I'm about to place my order for a book, Groovy Recipes is a very good book. I highly recommend it, yeah? But whatever book you choose, when you're getting ready to submit your order, you're not making an HTTP GET anymore. If you looked at the form, it would say form method equals post. And there are a number of reasons for that, of course. You might not want to have all the name value pairs up on the query string like that. You might want to have them included in the body of that. But it's the semantics of it as well. That GET is meant for retrieving these resources. Post, as you said, are meant for inserting new resources in. Have you ever been clicking back on your browser button? You go back, 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 back. What happens if you get to a form that's been an HTTP post? Does your browser warn you? It says, do you really want to submit this form again? And again, if you've bought Groovy Recipes, I say, yes, you do. Say, yes, okay, buy your additional books and it'll go. But I mean, most of the time, it's really trying to make sure that you don't redo those kinds of things that you might not want to redo. The $20 word for that are idempotent requests. An HTTP GET is idempotent. You can get over and over again, and it won't change the state of the server. But if you do an HTTP post, or a put or a delete, as we'll talk about here, those are non-idempotent requests. So GET is like retrieving, post is like inserting, put is for updates, PU, update, U is in there, put is for updates, and deletes are for deletes. What you're beginning to see now is you're beginning to see a CRUD formation happen, aren't we? CRUD, create, retrieve, update, delete. I could sit you down in front of any database, couldn't I? And if I said, quick, get me all the records out of the person table, what would you type in? Select splat from person, semicolon, right? If you wanted to insert into the database, you'd say insert into person. If you wanted to update, update person. If you want to delete from person, delete person. We have SQL. That means that whether we're dealing with Oracle or Postgres or MySQL or any of these databases, we have a standard set of verbs we use to interact. REST is like the SQL of web services. Whatever RESTful web services are out there, you instantly know how to deal with it through get, put, post, and delete. And just like primary keys in a database are the way you uniquely identify records in a database, what you're looking up at here is a URI. Now, most of the time we call them URLs, Uniform Resource Locators, yeah, but Rastafarians call these URIs, Uniform Resource Identifiers, exactly. This is the primary key of that record in the web. Does that make sense? Yeah. It's remarkably simple once you look at it, but having explained to you, you say, oh, yeah, I do that all the time. So let me show you briefly how you could set up a set of RESTful web services in Grails. Now, Grails is a web framework that is implemented in Groovy, but it's really Spring under the covers. It's Hibernate under the covers. It's Xerxes, it's Ant, it's JUnit. It's all the Java classes you would expect. But if I come in here quickly and I'm able to say Grails, create app, let's say I want to create a bookstore. Excuse me. Grails will blast out a directory structure for me. You'll see that there's now a bookstore in here. I come into my bookstore and I say, well, you know, I probably would like to sell some books if I could, so I'll say, please create a domain class book for me. Creates the domain class and the unit test, very important, you're testing, yeah? And we come in here right now and say, if you would please, I'd like to create a controller for my book class. So we come in here right now. Here's my bookstore application with my domain class book. Come in here and I say, well, a book ought to have a title, a book ought to have an author. Yeah, that's probably good enough for right now. And I go into my controller and I say, I'd like you to scaffold this out for me, please. I'd like you to give me a full CRUD application. So how many lines of code have I written so far? 1, 2, 3. That's about enough. I'm kind of tired. Let's go ahead and run this application, don't you think? Yeah. So what I'm going to do is I'm going to come in here. This is an example I use quite a bit. So I'm going to clean, and then I'm going to do a quick Grails run app. Grails ships with its own servlet container, Jetty, but I can type in Grails War and deploy it to Tomcat or JBoss or WebSphere WebLogic. Grails ships with its own embedded database, HSQLDB, but I could point it to Oracle or DB2 or MySQL. And in that amount of time, I now have a web application up and running at localhost 9090 bookstore. Let's see what that looks like. Ah, there we go. I can come in here. My buddy Mark Richards is in the front row here. What's the title of your book, Mark? Java Message Service. All right. Because he's got another book out. You know, it's probably less understood, but he's also written a book called Fun with Cheese. So yeah, you get the idea here. Lots of things, and I'll add myself in here as well. So Scott Davis has a book, GIS for web developers, and we could go on, but you can see this is a full application in here, something that allows me to sort out my columns, allows me to do the full create, retrieve, update, and delete. You know, my standard joke is he's got a new version of this book out right now. It's really good, Fun with Cheese 2.0. I highly recommend it. You know, so we begin seeing that I've got this much coming on. Isn't Grails amazing? I love this web framework. It's incredible. But we're here to talk about RESTful web services. And so being able to come back to Grails, where are you at, Grails? You're hiding from me. There we go. Being able to come back to Grails now in this controller and be able to say, all right, well, I want to pull in my converters class. So now, in addition to scaffolding out all that HTML or create, retrieve, update, delete kind of things, I also want to be able to come in here and be able to get an XML list. Render book list as XML. One line. I could also do a JSON list if I wanted to. I could do the same thing, render book list as JSON as we come along in here. So being able to not only provide the HTML interface, but being able to provide, I got to spell it correctly, the XML representation of that. Yeah? And again, one line of code as we come along in here. If we had more time, I would take you through the entire create, retrieve, update, delete cycle. But if you Google for mastering Grails REST, this is an article I wrote for IBM Developer Works that walks you through how to do the full get, put, post, delete version of these kinds of things. And you'll see at the end of it, I'll pull this up in just a second, but as you'll see, it's about 50 lines of code, all told and done, to implement the get, put, post, and delete. Oh, the internet has been so friendly to me, and now it goes away. Okay. Well, mastering Grails RESTful web services. We'll check back on this in a moment here, but about 50 lines. And as you would imagine, you just switch on the method. Switch, request method. If it's a get, do this. If it's a post, do this. If it's a put, it's a delete. And in each case, it's 2 or 3 lines of code to do that. Disappointing. All right, we'll come back to it. So are you beginning to get a flavor for what I'm talking about here? This is a very low ceremony way of dealing with web services, but it's not for toy applications. This is written by a doctoral dissertation. This is really a high capacity, high availability way of managing this. And if we start looking at the YouTubes and the eBays and the Yahoos and the Googles of the world, they're all providing RESTful web services. So we know this is very clearly ready for prime time. So coming back now, SOAP, S-O-A, is an SOA implementation. So we now know what REST is, representational state transfer, a resource-oriented architecture. But what implementation can we use? Some people like arguing SOAP versus REST, REST versus SOAP, but that's really two different terms. We need to either argue an architectural style versus an architectural style, which is perfectly valid. RPC versus resource-oriented, fine. Or we need to argue implementation versus implementation. SOAP versus what? Yeah, HTTP, yeah, but we're going to take it a little bit farther. You're absolutely right. So, what we have here is something you're probably very familiar with, syndication. If I pop up this, you've probably seen these t-shirts, right? I'm blogging this. And this is the 21st century equivalent. I'm tweeting this. Yeah. But all these are predicated on this notion of syndication. What does this symbol mean? RSS, good. That was a trick question. You're absolutely right. But RSS is one implementation of syndication. There's also Atom. And there are a number of different ways we can implement this. So SOAP is an implementation of SOA. RSS is an implementation of syndication. And you'll see syndication has a couple of key concepts. It definitely has chronology baked into it. When you go to a blog, you're always going to get the most recent blog entry first. But syndication goes beyond that simple temporal notion of a blog. Because when we go to Amazon, we always want to see the latest books. I worked for a company, OpenLogic, in the States, where we were writing an installer for open source. So very big Fortune 100 companies would want to know when the latest version of JBoss shipped, and the latest version of Ant, and bug fixes, and critical patches, all these kinds of things. We were able to set up an Atom feed for this. And what was interesting about Atom is not only did it have this chronology, but in Atom it supports multiple MIME types. So we could have an HTML version for the systems administrators to read, but we could also have an XML version that our daemons could read, our applications that are running in the organization pulling these feeds down. We could even have a MIME type for the gzip files so that we could pull down the binaries of those particular patches as well. So you can see this goes far beyond simple blogging, this notion of syndication. Syndication comes to you. Now we know that this is all based on HTTP, and so you do have to get, but I mean the polling nature of this makes it appear as if it comes to you. And yes, these permalinks that have become so popular in the blogosphere, what are those really? URIs, once again. So we have blogging systems that are actually incredibly RESTful as they're implemented. We have things like YouTube. I have a 7-year-old son at home. He loves Legos and he loves Star Wars, so he really loves Lego and Star Wars together. Yeah. But we can see up in that corner, right next to the name, we have a subscribe button. And so wherever we go, there's this notion of we want to keep track of this information. We want this information to come back to us, whether it's JBoss bug fixes or the latest blog entry or the latest video by Lego Dude 123. This syndication, again, has kind of faded into the woodwork. It's out there in various implementations. We don't even think about it anymore. This is a very good book that focuses on the two most popular standards for syndication, RSS and Atom. And you'll see that there are libraries out there that you can use. This is Rome, which, boy, I know it's very small, hard to see, but the acronym is for, let me see if I can find it here. RSS and Atom utilities for Java. So the R is for RSS. The OM is for atom. I mean, they really had to struggle to come up with this acronym. It's not a very good name, but they do say that all roads lead to syndication, and I do like that. Rome is a Java library that speaks RSS, that speaks Atom, that makes it very easy for you to incorporate this into your application as well. So focusing on RSS, RSS is very much syndication 1.0, much like SOAP. It was the earliest implementation, so it's the implementation we're all familiar with, but there's some problems with it. First of all, we can't even agree what it stands for. Some people say that it stands for RDF, Site Summary. Any fans of semantic web out there? Yeah, I mean the semantic web, RDF Site Summary. And then someone else says, well, it's this rich site summary, or really simple syndication. And now, much like SOAP, it doesn't stand for anything. It's just 3 letters. The problem with this is that out of all these different versions out there, we find that Netscape was releasing several of the versions, and Dave Weiner, remember Dave Weiner, right? Mr. SOAP as well, was releasing versions as well. Netscape was really trying to push a semantic web version of this, and Dave Weiner is looking for a very simple, easy set of specifications. And so at some points, like RSS 0.9.1, they're both numbered the same, but they're mutually incomprehensible. They're 2 different frameworks that have the same version number. That is a problem. Yeah? So even though RSS is very popular, you can see it's had kind of a tumultuous childhood. But it's still perfectly valid as a format. If we go out to Yahoo, we'll see they present their weather as an RSS feed. Whoa, problem loading page. All right, let's see if we can do this version. A good developer always has the page pulled up, doesn't he? Yeah? I'm hoping that I'll be able to live demo it, but if not, they provide this weather feed to us as an RSS feed. Why do you think they choose RSS for this? Maybe because weather has a very temporal nature to it, very time-oriented nature. You don't want the weather from last week or last month. When you make this web services call, you want the current weather. You want today's weather right now at this moment. And so they chose RSS as the way to serve it up. No network, bummer. But we do much the same thing. We make a RESTful call, you pass in a zip code. This is US only, I apologize about that. But it'll return an RSS response. And eventually, there we go. We'll be able to see that this RSS response has a channel and gives us the weather information, in this case for Sunnyvale, California, forecasts and everything else. So normally I would do a live presentation of this. Doesn't look like we have any internet anymore. You must be ready to go home, yeah? Don't worry, only 2 more hours and then we're done. So sit tight, we'll be fine. Yeah, no, we're getting very close to the end. So this gentleman, Tim Bray, is considered the father of XML. And Tim Bray sat back and said, you know what, I like the idea of RSS, but Dave Weiner and Netscape constantly going back and forth. We need a way to standardize this. And so Tim Bray and a number of others came up with an Atom standard, which is an IETF standard. The IETF is the same organization, yeah, that publishes these RFCs on URIs and MIME types and everything else. And so Atom brings you all the power of RSS, but it's also a standardized way to manage that. RSS also has one other problem, and that is very RPC oriented. RSS defines how you get those entries, but it doesn't define how to add new entries, or delete entries, or update existing entries, yeah? And so RSS is very good for pulling down a feed, but not so good for the other CRUD methods. And so what Atom provides is a way for us to do that. We can now say that SOAP is an SOA implementation and Atom is an ROA implementation, because it gives us the verbs, the get, the put, the post, and the delete in order to do these kinds of things. And so Atom is one standardized way. As I said, at OpenLogic, we used Atom as a format because as we were pulling these things down, we could define different MIME types inside of it. We knew that Atom wasn't a format that was thrashing about. We knew that Atom was a standard and very stable. There are many other people who are using Atom as well. Little company you might have heard of called Google. Yeah? Do you have Google here? Yeah? Yeah, of course. Yeah. In December of 2006, Google officially deprecated their SOAP APIs. They said there's nothing wrong with the SOAP APIs. It's the product that was our first API. It inspired a lot of our other services. But you have to realize that this is 1999 technology. And we're sitting here in 2009. 10 years later, we're looking for an API that reflects the modern sensibilities, the best practices of current software development. And so Google deprecated its SOAP API and has rolled out all of its new APIs in a RESTful way. They call it GData. But what GData, Google data, actually is a Google set of APIs that provide an RSS format for read-only data. You can get an RSS feed for your calendar and some other things like that. But if you're going to interact with any of these APIs, you need to understand Atom. Because Atom is actually the preferred API. So for your calendar, the way you add new calendar entries programmatically, the way you update calendar entries, the way you delete entries from your calendar is all through Atom. If we had a live internet connection, I would show you some of this stuff. If you are ever looking to implement a RESTful interface in your organization, I highly encourage you to go read the documentation. Any of them would be good, but specifically the Calendar API, because the Calendar API will talk about authentication. There are public calendar feeds you can get that anyone can request, and there are private feeds where you need to log in. Obviously, you need to be authenticated in order to update and delete entries. And so these are very well documented, and it's a wonderful way of looking at a RESTful Atom set of web services that you can implement and you can emulate, you can imitate in your organization as well. Excellent set of documentation. So, Twitter also has an Atom feed. And this is usually how I like to end the presentation. How many of you are on Twitter? Yeah? Have you been twittering? Have you been tweeting with hash JDD and things like that? Well, if I would have had a live internet connection, I would have been able to see what you were tweeting right now. Unfortunately, the internet connection is down. But once again, we can see the type of request I would make. Search Twitter.com, search.atom, and the query would be JDD there. Or the username, ScottDavis99, or whatever you wanted to query out of that. And once again, you would see it was exactly like the RESTful geocoder example we did earlier. It was exactly the same as the rhyming geocoder that we did. It would have been exactly the same as the Yahoo weather RSS feed that we were pulling down. This would be a RESTful API that we could pull down and see all the tweets that have a certain keyword in them. Go ahead and try it when you get back home. It's really fun being able to get this stuff programmatically as well as through the web UI. So, in summary, which is the best word to hear in a keynote, isn't it? In summary, in conclusion, you're almost ready to go home now. Yeah? We see that ROA, Atom is an ITF standard, that it's RESTful, that it's a syndication format, that it's all of these kinds of things. We now understand the arguments of REST versus, or SOAP versus. It's entirely appropriate to say, well, let's evaluate SOAP for our organization, and let's evaluate ATOM for our organization. It's entirely appropriate to say, let's take a service-oriented approach, an RPC-oriented approach, or let's take a RESTful approach, a resource-oriented approach. And I'm not suggesting that one is better than the other or worse than the other or always appropriate. But what you will find is out in the wild, the Googles, the Twitters, the Facebooks, the YouTubes, the Flickrs, all of these Web 2.0 darlings are providing you a RESTful API into your services. And so if you look at the trends as things are going, SOAP is not dead. SOAP isn't going away tomorrow. But SOAP is on the downward slide of the adoption curve, and REST is on the upward slide. And so every organization needs to decide if they want to be implementing the last decades, the last centuries APIs, or if you want to be implementing the next decades APIs. And I certainly think REST falls into the latter category. Did you enjoy yourself here this evening? Yes. Thank you so much for your time and attention. I really do appreciate it. I believe we have some closing words here, yeah?
Raz. Okej, to na zakończenie konferencji chcieliśmy Wam wszystkim podziękować. Chcieliśmy podziękować sponsorom. Przyszedł ten wyczekiwany i sympatyczny moment dla cierpliwych osób, które zostały do końca. Mianowicie mamy dzięki sponsorom dość dużo nagród. Koledzy wnoszą. Tak, na początek mamy nagrody z firmy B2B za oddawanie ankiet, które były zbierane u nich na stoisku. Zapraszam przedstawiciela firmy B2B do rozlosowania urządzeń wielofunkcyjnych. Poczekajcie, mamy też później książki z podpisami naszych prelegentów, mamy dużo ciekawych rzeczy. Okej, to jeszcze, jeżeli ktoś jeszcze nie oddał ankiety, to bardzo proszę oddawać nasze ankiety. Okej. Czy są jakieś hostesy, które by bardzo ładnie przeszły przez środek sali i pozbierały resztę ankiety?
Is this, still on?